Hello. Welcome to the Tech Geek Podcast, folks. I'm your host, Sukriti. Thank you so much for tuning in. Now, I'm here with another interesting episode and concept, which is actually about how technology is actually, using, amending, innovating the intelligent system design behind the chips that we may call. So, electronics technology is proliferating to a new creative applications and appearing in our everyday lives, as all of us know. And to compete, the system companies are actually increasingly designing their own semiconductor chips. Semiconductor companies are actually delivering software stacks, enabling optimization across software and hardware for the substantial differentiation of their end products. Now, such trends have started in the mobile devices and now is moving to the cloud, automotive, and other areas. Hyperconnectivity, generation of zettabytes of data increases the importance of application-specific optimization of the silicon performance in the context of the system, as well as the system itself across boundaries of hardware and software, analog and digital, electrical and mechanical. Now, in addition to all these things, to know more about this, as well as decode the whole technology behind intelligent system design for the chips, I'm in conversation with Dr. Alok Jain, Vice President System Verification Group from Cadence. Welcome to the show, Alok. I'm so delighted to have you here for this conversation.
Hi there, Sukriti. Good to be truly here, and thanks for this opportunity.
Hey, Alok, thank you so much. And I am equally delighted to have you here with me. To get started with the questions here, I would like to start with that, how is your company actually leveraging its deep expertise in computational software for intelligent system design?
Okay, good question, Sukriti. So, Sukriti, as you are aware, Cadence is in the business of developing software to help design electronic chips and systems. Now, as you know, electronic chips are everywhere today. So they're in our cars, they're in our phones, lots of chips in the cars and phones. In fact, probably an electronic chip is there in every household gadget that we use today. Now, Cadence has been helping design these chips over the past 30 plus years. And during these times, we have developed a deep expertise in the domain of computational software, right? And today, what we're trying to do is use that deep expertise that we have developed and bring intelligent system design for upcoming future products. Now, just to give a few thoughts on what we are doing there, in terms of the system space, we are trying to optimize all aspects of the system space. So not only are we trying to optimize power performance area, but we are looking at aspects of security in the system space. We are looking at electromagnetic and thermal patterns in the system space. And all this is coming because of our deep expertise in computational software.
Okay. And to connect with the above statement of yours, Alok, what is the system verification and why does it need simulation here?
Okay, so Sukriti, as you mentioned, I'm from the system verification group at Cadence. Now, the goal for system verification is to actually verify or check, does the system do what it's supposed to do? Now, let me start with a simple example. Let's assume I designed a multiplier. Now, Sukriti, just to clarify, a multiplier is not a system. I'm simply using it as a simplified example to illustrate what's happening. So now a multiplier is supposed to multiply two numbers. Once I have designed a multiplier, I want to check, does it actually multiply? One way to do this is give it any two numbers. Let's say I give it 4 and 5. And then I check, is the output 20? Similarly, I give two other numbers, let's say 7 and 8, and check if the output is 56. This is simulation. Now, basically what you do is you build a model of this multiplier in something called a hardware description language. Then you supply some set of input patterns or vectors, simulate it, and check whether the output pattern is the expected pattern. Now, this was a simple multiplier. Let's now try to scale it to a full system. It'll bring lots of complexity, including modeling aspects, abstraction aspects, heterogeneous systems, scalability. But once you have met all those challenges, you have a system level simulation that can actually be used to model a car, for example, and then simulate to see when I press the accelerator, does the car actually move forward? So this is system level simulation. Now, just one more note here. Apart from system level simulation, there are other aspects of verification that we look at. So for example, there are formal techniques their emulation techniques, and their virtual prototyping techniques that can also be used for system verification.
I see. So, now exactly, I think wherein we can actually talk about how technologies like AI is innovating the whole um, arena of intelligent systems. Tell us, what is AI-driven and intelligent system analysis, Alok?
System analysis and design is a very complicated process. I'm not going to go into all the details here, but let me talk of two specific aspects here which make it very amenable to an AI-driven system. So one aspect of that is inherently system analysis is an iterative process. What you do is you change one variable or change something, study the impact, based on an impact, change something else, and then go on from there. So there's lots of iterations. Now, once you have lots of iterations, it actually gives us the opportunity of using AI or machine learning kind of techniques. What we can do is look at the iterations that have happened so far, do some learning based on that iterations, and then subsequently do the further iterations in a much more efficient and automated manner. So that's one aspect that makes it very amenable to AI and ML techniques. The other aspect of system analysis is that today, when we are trying to optimize, we actually try to optimize multiple variables. Now, this is opposed to the past. For example, in the past, when we are trying to optimize a system, maybe you are trying to optimize only one variable, example, the system level performance. But today, it's actually a lot of different parameters that you're trying to optimize. You'll be optimizing performance, power, area, electromechanical, thermal considerations. So there's lots of different objectives that you have. And here again, AI and ML can be a big step in which you can try to concurrently do all these optimizations. So given the value of using AI for intelligent system design and analysis, Cadence has actually churned out a lot of AI-based platforms. So just to give a few examples, we, for example, have Cerebrus platform that's used for chip design. We have the Virtuoso Studio that's enabled with AI for mixed signal designs. We have Verisium for verification, productivity, and debug, Allegro X AI for PCB design, and finally Optimality for what we call multi-physics simulation and optimizations.
Okay, so you've enlisted a couple of products for us, and you've just helped us understand the whole functionality here, Alok. What are some of the important points to remember when one is strategizing an intelligent system design strategy?
So Sukriti, we sort of talked about this, but let me summarize this into three angles or three different things. The first aspect that's very important when you try to strategize for intelligent system design is to understand the domain of system level design. So you want to understand, for example, what are the problems, what are the challenges, what are the potential solutions in system level design. Let me just take a very simple example. I'm trying to design a racing car. Now, what I want to take a look at is what is the effect of wind drag on the racing car? Now, what are the potential problem solutions that are there in that space? So that's the first aspect, understanding system level design. The second aspect is we obviously want to use our core competence in computational software that we talked about to solve some of these problems in a much more efficient and automated manner. Now, let me go back to the example of the racing car. The question now is, can we somehow use our expertise in computational software to do some sort of a multi-physics simulation to see the effect of wind on the car? So this is simulating the effect of wind on the car. So that was the second aspect. The third aspect, as we already talked about, is understand how we can use different forms of AI and ML techniques to gain further efficiency and productivity. Now, I talked about multi-physics simulations to see how the wind affects the car. Now, these simulations, as you can imagine, are computationally very, very expensive. So the thought here is, can we somehow use AI and ML techniques to make these simulations be much more efficient and automated? So those are the three aspects. Just understand system level design, use our core competence in computational software to solve these problems more efficiently, and then see how we can use AI ML techniques to gain more efficiency and automation.
Okay, fantastic. Now, let's have a little preview of what does the market look like, and from the technology and a techie's perspective, what are the things that one can see? So, to put it primarily here, what is the market size and adoption rate for this particular intelligent system design strategy as of now?
Yeah, good question, Sukriti. So, Sukriti, first of all, I don't have any India-specific numbers. So I don't have numbers for India. But if I take a look at worldwide, the TAM, the total available market, is truly big. It's in multi-billions of dollars, much bigger than the traditional EDA market that we and other vendors have been playing in. So the TAM is big, right? Now, in terms of what impact we are making and what is the adoption rate, I already mentioned to you some of the AI platforms that we have. Just to recount, that was Cerebrus for chip design, Virtuoso Studio for mixed signal designs, Verisium for verification, productivity, and debug, Allegro X AI for PCB or printed circuit board design, and Optimality for multi-physics simulation. Now, all these platforms are making an impact out there. Let me just give a few examples. I talked of Cerebrus. That's for helping chip designs. At this point in time, we have done multiple chip tape outs with the help of Cerebrus. And what's out there is that it's giving much better PPA. PPA stands for power performance in area. So we are getting much better PPA than traditional methods. And we are getting somewhere up to 10x productivity improvement. So that's examples of Cerebrus truly helping chip design. Let me take another example, that of Optimality. I talked of Optimality as one of the multi-physics platforms that we have. Again, we have used it in multiple different problems. And what we have seen is Optimality is giving us 10x faster design closure with much fewer simulations than traditional approaches. So you can see that these AI-based intelligent system design platforms are truly making a difference out there. And I think going forward, we'll see much bigger impact of this strategy as we go forward.
All right. Now, I think we can have a great conclusion when it comes to helping our techies for whom we're doing this podcast precisely, Alok, to let them understand that from a techie's point of view, what are the skills that one needs to build a career in this domain? And is there any specific course or a particular skill set that one can look at while progressing in their career here?
Yeah. So Sukriti, let me first talk of what are the skill sets needed, and let me club them into 3 different buckets. So the first bucket is what we need is a strong foundational in computational software. So I mentioned computational software as the foundation with which we are building this intelligent system design strategy. So the first one is a strong foundation in that. And it starts with some basic courses like data structures and algorithms, right? And then you go on to many more advanced courses on computational engineering. So that's aspect 1, right, of the skill set that's needed. The second aspect is knowledge of system and chip design, right? And again, here you start with some very basic courses like CMOS design, VLSI design, courses on verification and layout methodologies. And then you go into many more advanced courses on system level design. And you also need some level of knowledge of what we call hardware description languages. These are languages like Verilog, VHDL, and System Verilog. So that's the second aspect. The third aspect is, since we are using AI and ML techniques, fundamentals of AI and ML techniques. So there are lots of courses out there that will introduce to you concepts like big data, supervised learning, reinforcement learning. So I think those are the 3 broad skill sets. Again, summarizing: computational software, that's one. Second is knowledge of chip and system design. And the third is fundamentals of AI and ML techniques. Now, in terms, Sukriti, of where are these specific courses, what are the specific courses that are being offered out there? Courses in all these domains are actually available both online and from multiple universities, both in India and the US. So, for example, there are courses on data structures and algorithms. There are courses on CMOS and VLSI design. There are courses on AI and ML techniques that are available from platforms like Coursera and a lot of other online platforms offered by the universities. Now, one final thought, Sukriti, on this. What is Cadence doing specifically in this domain? So we actually have a few programs to try to train interns and students in the domain of intelligent system design. So firstly, we have a program to directly hire from the campus universities. So we are hiring students and training them in-house on hiring from the universities and training them in-house. The second is we have a program that we call the Talent Pipeline Program, or the TPP program. Here, what we do is we hire interns from the universities, and then we put them through a one-year training program on different aspects of intelligent system design. And it's only after a year that what we are going to do is place them in different departments or business units. So that's the Talent Pipeline Program. Finally, the third one is we have an ongoing university relations program. What we are trying to do here is build a relationship with some of the premier institutes out there, for example, with the IITs out there. And in building this relationship, what we are doing is we are also providing them Cadence tools, Cadence platforms for intelligent system design. Then we'll also guide them how to use these Cadence tools in their labs so that the students get exposure to these Cadence tools, and therefore can now progress on to engineers that can contribute to intelligent system design.
Fantastic, Alok. And I think this is one of the best things that I could have actually asked for when it comes to concluding this show. Thank you so much for appraising us with so many important factors that actually is involved in the whole intelligent systems design that we are looking at in today's time, and specifically when our audience when they hear the important elements being addressed for them, I think that is exactly what makes the whole conversation more interesting. So thank you so much for being here once again, Alok.
Thank you, Sukriti, and again a big thanks for this opportunity.
All right, folks. So that was Alok Jain from Cadence. Now it's time for us to wrap up the show. I'll be back with another episode very soon. Till then, stay tuned to TechGeek for all the latest tech updates and more such podcasts. Thank you so much.